So kites and trapezoids are different kinds of quadrilaterals. So what is a quadrilateral? It's what? Four sides. So the quadrilaterals we deal with the most are probably squares and rectangles. But there are several other kinds of quadrilaterals as well. So this one here is a kite. Okay, so let's read here. It says, Manuel draws a diagram of kite PQRS. So again, we name the kite based off of its vertices, the points where the angles are. And it says line QS is a line of symmetry. So line QS is a line of symmetry. What is a line of symmetry? You could fold it over that line and it would map directly on top of itself. So yes, that does look like a line of symmetry. He makes a list of conclusions based on the diagram. And so what we want to do is see if we think all of these things he said are true or which ones we think are questionable. Okay, so the first one says PR is perpendicular to QS. So what does it mean, perpendicular? What does perpendicular mean?
Congruent.
No, not congruent. Crosses at a right angle. So PR and QS are perpendicular. So I need Okay, third row. There we go. And then I got fifth seat. So if I do it like old school, that would be Aubrey. What do you think about that statement? Do you think that's correct or incorrect? Is PR perpendicular to QS? Yes, no, maybe, kinda, sorta not, doubtful? Why are you shaking your head yes, Grayson? Why do you think they're perpendicular?
Because they're at right angles.
Does it look like they form a right angle? It does. Looks like it could be a right angle, so I think this looks like it makes sense. Okay, so I will agree with Manuel on his first conclusion. The second one, he thinks QP and QR are congruent. Okay, well let's see. Sixth row and fifth seat. So it'd be 1, 2, 3, 4, 5. It'd be you. Do you think QP, that's the distance from here to here, is congruent with QR? I could see it. Right? That kind of sounds reasonable to me. So let's say that that one's also true. The next one says that SP is congruent with SR. Think so? I think so as well. That kind of makes sense. And the next one says that PR, that's this line here, it says that PR bisects QS. So do you think that this line, PR, cuts QS into two equal pieces?
Could be the other way
does look like it might be the other way around, but the statement they said that PR bisects QS. And so just by looking, I'm going to say no. That's probably not correct. The next thing they said triangle PQR is an equilateral triangle where all sides are the same measure. All angles would be 60 degrees. It's hard to tell, right? Looks like it could be. All right, let's measure. That one's close, right? So let's see. If I measure here, on this side, I'm getting 33. Right here, I'm getting 23. And right here, I'm getting 23. So, no, it's probably not equilateral. So I'm going to say that is probably wrong. And then triangle PSR is isosceles. Do you think this is an isosceles triangle?
Yes.
Yeah, I'll go with that. I bet this side PS and side SR are congruent. So you can see when we're dealing with these kites, we're going to have lots of properties of kites. And so guess what you're going to have to do? Learn these properties of kites to be able to draw conclusions about them. Okay, so here we're going to do some investigating about diagonals of kites. So what is a diagonal? A diagonal is a line that goes from one angle to the angle opposite it. So when we first talk about diagonals, we normally think about a square. Right? The diagonals of a square go from one angle to the angle opposite it. That's what makes it a diagonal. Why can't you draw a line to the angle right beside it? What if I drew from A to D? Well, I'm just drawing a side, right? It's not a line that exists outside of it. So when I look at the diagonals from A to C and from D to B, what are some properties of this? Well, we can see kites, they have two pairs of congruent adjacent sides. So like AB and BC, they have the same measure. They are congruent and they are adjacent, which means beside each other. And then we have AD is congruent to DC. Again, they are beside each other and they are congruent. Now, are all the sides that are beside each other congruent? No, because look, is DC beside CB? But they aren't congruent. Okay, but every side has another side that's touching it that it's congruent with. Questions about that? So you probably need to make you a little list of properties of kites. So I would say it has two pairs of adjacent congruent sides. Right? Something like that. It could be in your own words. You don't have to use my big fancy words. But you're going to have to be able to identify all these properties. So you got sides right beside each other that have to be congruent. Okay, then it tells me point B is equidistant from the endpoints of AC, as is D. So they lie on a perpendicular bisector. So we have a line here, BD is a perpendicular bisector. What does that mean? Perpendicular bisector. Cuts into two equal pieces. And perpendicular means what? Perpendicular. Y'all need to write down what that means. 90-degree angles. You got that, Corey? You writing it down? You taking good notes? Mm-hmm. You put your phone up. Thanks. I'm not going to do this the whole rest of the year. I'm sick of it. Here, from A to C, you see how line DB is perpendicular, 90-degree angle, bisects, cuts into two equal pieces. Okay, so I'm going to ask these three questions to you guys. What is the measure of angle AXB? So that would be from A to X to B. What is this angle measure?
90 degrees.
How do you know it's 90 degrees? Because it is perpendicular. Absolutely. The next one, you guys try it on your own, and I'm going to roll the dice. If AX is 3.8, that means from A to X is 3.8, then what's the distance from A to C? I don't want you to think through that. Alright, we got our answers? Okay, let's roll. Fourth row. Fifth seat. Alright, Corey. What's the measure of AC? Okay, can you draw where AC is at? Yes. So from A to C is this line here. That's what I'll put it in a different color. Red. Alright, so I want to know the distance from A to C is red. I want to know what's that distance of the red line. Okay, what do we know? From here to here is 3.8. Okay? And so that means this side is also 3.8 because it is bisected. Okay, so what's the distance of the entire line then? Seven. 0.6. Carry the 1, right? Okay? So the distance of AC is 7.6. Questions there? And C part. C part says if B to D is 10, does BX have to be 5? Okay, so they're telling me the entire distance across from B to D is 10. I want to know, does BX have to be 5? So that would be this one here. Why not? Or why? I heard somebody say no. Why not?
Because, as you can see, it's not split in the middle.
Right.
Like there, B or XD is a lot bigger than XB.
So remember, when we have these diagonals that intersect, only one of them is a bisector, right? DB bisects AC. It cut AC into two equal pieces. But it didn't go the other way around, right? AC doesn't cut DB into two equal pieces. And you can tell just by looking. There's no way that this distance is the same as this distance. So because even if we know the whole thing is 10, that doesn't mean it's cut into segments of 5 and 5. Okay, so here we're taking our properties that we know about kites and applying it. And what it's asking me for is what's the measure of angle 1, the measure of angle 2, and the measure of angle 3. So the thing that looks a little tricky here would be identifying where all these angles are. So the 35-degree angle is talking about angle QPT. Right? This angle here is 35 degrees. I'm looking for angle QPT. I'm sorry, angle PQT. Right? That's angle 2. I'm looking for angle RTS, which is angle 1. And I'm looking for angle QRT, which is what they're calling angle 3. So, what did we just learn about the diagonals of a kite?
They go from one angle to the other.
They do. They go from one angle to the other.
That are across.
Not the touching angle.
And
Where they meet is perpendicular. So that means what? All of these angles are 90 degrees. So do we know what angle 1 is?
Yes.
What is it? 90. Angle 1 is 90. Does that make sense? So now if this is 90, that means all of them are 90, including this angle. Angle QTP would be 90 degrees. So now could we find the measure of angle 2? How?
Add 90 to 35 and then subtract from 180.
Why? Yes, you're right. Why? How do you know you can do 180?
Because
the interior of the triangle.
There's a triangle. What triangle are we looking at? Name it.
QTP.
QTP. Does everybody see this triangle? And so we know the three angles have to add to be 180. So we could say 90 plus 35 plus x has to be 180. And then subtract 180 from 125, and we would find that angle 2 is a 55-degree angle. Questions there? Okay, now let's look for angle 3. Why?
Because since it's QS splits the entire thing, and if you fold it, it's line of symmetry.
Okay.
P and R are the same
Okay.
thing. Yeah,
Okay.
that makes sense.
It does. So what he's saying is, if he folded it over QS, that's a line of symmetry. So if angle 2 had to be 55, then that means angle RQT is also 55. That's one way you could do it. Anybody think of it a different way? Because that's not the way I thought of, but that works. Okay, so for me, what I see is I see a different triangle. I see triangle QPR. What kind of triangle is that? It's not equilateral. It's isosceles. I have two sides that are congruent to make an isosceles triangle. I know isosceles triangles have congruent base angles, which means angle 3 and 35 degrees have to be congruent. Therefore, this missing angle 3 is 35 degrees. Is there probably more ways to do it? Yeah, probably. Right? You just have to pick one. Makes sense to you. And work it out. Questions here? Okay, I want you guys to try this one, and then we'll roll the dice. All right, who thinks they got the measure of angle 1? Grayson feels good about it. Anybody else? Aubrey thinks she's got it. Anybody else? Maybe. Is that what that means? Maybe.
Yeah, maybe.
So Bryce is thinking maybe. Let's see. The person who's going to tell us is sitting on the third row. In the. Why did I roll? In the third seat. Yeah. Get fired up. What'd you get for the measure of angle 1?
53.
53. Tell me how you got 53.
Is that right?
How'd you get it? I'm not telling you yet. You just felt it? It's close. This one say you probably were doing it correctly. If you tell me how you did it, I might know if you were doing it correctly. You don't know? Right, somebody, how did you get it? Go ahead.
You add 90 and 32 degrees together because where they bisect is.
So right here where the diagonals bisect is
90 degrees.
perpendicular. And then you were focusing on what triangle?
The
Name it.
XW.
X, W, and then this doesn't have a name, does it?
Mm-hmm.
Let's call that point P. Okay, so if I focused on triangle XWP, those three angles should add to be 180. So I could call this X, this one 90, and 32. Okay, and so then you told me to do what?
Add 90 and 32 together.
Add 90 and 32. That gives me 122. Okay?
Then subtract 180 from, subtract 122 from 180.
Okay. And you got
58.
58 degrees. Okay, so the measure of angle 1 should have been 58. Does everybody see how we got there? Any questions? Okay, what about the measure of angle 2? It's what?
The same.
It's also 58? It's 32? Okay,
It's the
X.
same as x, p, y, just
Just
three line of symmetry, all the
Okay,
angles are the same.
so Grayson's all about this line of symmetry, right? So if he were to fold it over this line of symmetry, it would map directly on top of itself, which means these two triangles would have to be congruent. So this one would also be 90, this would also be 58, which means this has to be 32. That could work? I'm in. Okay, another way you could have done it, you could have taken this part out and then looked at this triangle. This triangle would be isosceles. So I knew if this was 58, the other one would have to be 58, which means 32 and this missing one would have to add to make this entire thing 180. That way it's definitely harder. My way's harder than Grayson's in that one. Not even close. So I would have done it Grayson's way as well. Okay, but that's just a different way to look at it.